Hi guys, so today we're talking about using linear relationships within the data set. So given the data table, can we predict what the graph is going to look like? And will this particular data set be linear? How do you know? So here's just a quick data example. It says Miss Chang's class decides to use their money from the walkathon to provide books for the children's ward at the hospital. They put the money in the school safe and withdraw a fixed amount each week to buy new books. To keep track of the money, Isabella makes a table of the amount of money in the account at the end of each week. So a couple key things here. They are subtracting money from the safe each week, so once a week, and it's a fixed amount. What's a fixed amount? It's the same. It's a consistent amount that's not changing. So it's the same amount every week. And that's important because it identifies a pattern in the data, right? So at week 0, they have $144 in the safe. So that means that's the money that they earned. There hasn't been anything taken away yet. It's the very beginning of this project, and this is what they're starting with. So after week 1, they have $132 left in the safe. So how did they get from $144 to $132? Well, they subtracted 12. To get from week 1 to week 2, $132 to $120, they subtracted 12. Again, you see where we're going with this. The pattern's going to continue because, first of all, it tells you in our little blurb here that it's a consistent amount or it's a fixed amount, so that means it's the same amount every week. And the data table goes week by week by week. So 0, 1, 2, 3, 4, 5. We know that the data is going to be consistent, so every week you're taking away $12. Is this a linear data set? Absolutely, because there's a pattern. You're following the pattern. For every week you progress, you are taking out $12 worth of money from the safe. So we can look at the data table and we know the graph is going to be linear. This is problem 1.4. It's a little extensive. We're not going to go through everything, but I just want to talk about how you use the data table to answer some of these questions. So part A, the first question says, how much money is in the account at the start of the project? We know that. It's week 0, and in week 0, there's $144. It says, how much money is withdrawn from the account each week? Again, $12 is withdrawn every week. We've already examined all of these things, right? So it's just asking you very deliberate, precise questions. Is the relationship between the number of weeks and the amount of money left in the account a linear relationship? Yes, it is. Why? Because there's a pattern here. For every week, we're losing $12. So that means on your graph, every time you move over one space to the right with your dependent variable, you're going to decrease 12 spaces vertically on your dependent variable. Number 4 says, suppose the students continue withdrawing the same amount of money each week and sketch a graph. You guys know how to make a graph. We're not going to do this. If you will do it in your notes, that would be helpful. It'll give you a little extra practice. Number 5 says, write an equation that represents the relationship. Explain what information each number and variable represents. Now, we do need practice with equations. Write an equation. We have 2 variables, right? One is the number of weeks. So week could be W. And 2 is the amount of money. What's left in the safe? And that could be M. It's up to you what you label your variables. So which variable is independent, which is dependent? The week is independent, right? Week is what is not changing. The money is changing. So the money depends on what's happening to the week over here. Now, at 0 weeks, we have $144. So that's important to show. Every week, we take away $12. But how do we account when we have multiple weeks? So during the first week, or at week 0, I have to have 144. At week 1, I have to have 132. At week 2, I have to have 120, and so on and so on. What you can do is, our week is this variable here. How do we affect the number being taken away? Well, if you're taking away $12 each week, but the first week, week 0, you're not taking anything away, the first clue you should have is that there's a 0 there. Zeros are pretty important when we're writing equations because they make a product of 0. What's a product? The product's the answer when you multiply something. So if I have 12 times 0, I get 0. For 144 minus 0 equals 144. That's the data point that I need. Now if I have 12 times 1, oops, that's 12. 144 minus 12 gives me 132. That's what I need. So what am I consistently multiplying 12 by? Well, I'm multiplying it by the number of weeks, or W. The way to check your equation is to simply do what I'm doing. Go through the table and plug in the number of weeks, and make sure that when you solve this side of the equation, it equals the correct amount of money, right? So it's really write what you assume is the best equation, and then go back and check, fill in those blanks. The more you practice this, the more you'll be able to realize after 1 or 2 coordinate points, oh great, I got it right, I can move on. It's not a very time-consuming process once you become more skilled, but at this point it may be a little frustrating, so it's really important to look for tricks like the 0 that you know is going to be multiplication, or some other kind of circumstances that I'll explain as we go on. So this is a little graph. It says Mr. Marmer's class also raised money from the walkathon. They used their money to buy games and puzzles for the children's ward. Sadie uses a graph to keep track of the amount of money in their account each week. Is this graph linear again? Absolutely. We're starting right here. We go all the way down. Couple questions about the graph. Let's move these over here since we're not familiar with this. So the first question says, what information does the graph represent about the money in Mr. Marmer's class account? Well, there's a couple of important pieces of this graph. I like to say there's significant points. That's going to be the beginning, the end, and maybe 1 or 2 points in the middle that intersect nicely in the grid. So that's a really great point to look at. You're also going to want to look at the decrease going week by week. You know this is linear, so if you figure out how much money they lose between weeks 0 and week 1, or week 1 and week 2, you know how much money they're giving away every week. Okay? So this is all important information to know. The rate of change is the amount of money given away every week. The unit rate is very similar. We'll explain that definition further during the next video, and the same goes with the solutions to a linear equation. You're going to get more practice with that as we go on, but it's basically that guess and check method that we talked about before. Okay? Make sure your notes are thorough. If you want to graph that example, that would be really great, and you would have a lot of practice with that.